So workforce training is very crucial when it comes to exploiting the benefits of silicon carbide applications. Do you think gallium nitride ecosystem is facing the same human resource problem?
Absolutely. It's the exact same situation. So if you look at commercial devices from a new technology, there are some new aspects, right? And in order to be able to do those new aspects, you need people to be trained. If people do not shift to GaN, then you will not have volume production and you're going to be too expensive. So the only way for a new technology to move forward, apart from telling everybody it's got some compelling properties, you need to teach people how to utilize that technology. Now, if you take a circuit that has silicon and you pull out the silicon part and you replace it with GaN, you will see very little improvement, if any at all, and if you don't burn the circuit, okay? Same thing with silicon carbide. If you take a silicon circuit, take out the silicon MOSFET and put a silicon carbide MOSFET, you will not see any improvement. So you need to basically have a trained workforce that is capable of fully exploiting the properties of these devices and inserting them in systems. For example, you have high frequency operation. High frequency operation will shrink many passive components. So you need to understand how that works. And at that high frequency, you're entering into the RF type of technology. So you must understand how you do RF layout for the PCB. Another one is the magnetics, right? If you're going to be operating at high frequencies, you need to have magnetics that are capable of doing the high frequencies, right? And of course, because of the high frequency, because of that fast switching, inductance becomes a real problem. So you need to be able to do layouts that minimize the inductance. The other thing is, because it becomes very compact, then whatever heat is generated, you have to dissipate that heat very efficiently. So you really need good thermal management. And of course, the way you drive the device is different than in silicon. So you need specific gate drivers. And of course, because of the high frequency, you're able to do new topologies, right? And that gives you a huge advantage, topologies that are impractical in silicon. So you need to have an understanding of how those works to fully exploit the benefit of gallium nitride. So the bottom line is you need a trained workforce all the way from making the epitaxial layers, minimizing the defects there, making sure there's thermal conductivity, doing the packaging that will allow the device to operate at high frequency, doing simulations, doing PCB layout, RF, magnetics. So there's a whole bunch of things. So the idea that, hey, I know how to do silicon, and here's a device with better properties, now I'm just going to use this device in my circuit, is not enough. And I think you guys in China have an extremely good educational system. I'm very, very impressed with all the Chinese students and professors that I encounter in the United States. So you have an extremely good system, and it's that availability of students and human resources that will build the future in your country. There's a lot of people that are good in math and physics and enjoy doing integrals and differential equations and all that. So there's a really, really good future. But in my mind, for any country to succeed in inserting these technologies in systems and being successful, it has to have a very rigorous program, number one, to take students and train them. Number two, to take the existing workforce. It's not enough just to train the next generation of people. You got to take the people that do the work there today and train those people as well. The thing is, when you're a little older and you have a secure job and you have a family and you want to save for your kids' university, for your retirement, it's very risky to adopt a new technology that you don't understand. Because if something goes wrong, you're going to be in trouble with your manager. So if people don't understand a new technology, they're not going to do the new stuff. So unless you train them and builds the confidence in them to use these new technologies, then it's not going to go anywhere. And I actually talked to some people from Taiwan recently. And as you know, Taiwan is going to be opening fabs in the United States. And they understand that really well. They understand that when they come to the United States, the talent might be limited. And they're already looking for ways to do the training, staff their founders. And if you look into the United States, it's been announced and it's in the process of being approved of a $52 billion investment in chips. The question that I'm asking is, who's going to do $52 billion worth of work? Who is trained enough to go in and do, a lot of that stuff? So I think, part of the success of a country in these new technologies is the workforce, the people. That's the biggest investment that you need to make.